Hello, my name is Mr. Asprey and this is MADAS Maths Pure Synoptic Paper B. These papers are really tricky and they're great practice for doing A-level maths, whether you're doing EDEXCEL, OCR, MEI or AQA. It's great practice. If you do find the content useful, please do like the video. If this gets over 50 likes like the previous one did, then I will definitely carry on and do the next paper. And please do subscribe to the channel because I've got lots of A-level content and that will be really helpful. Okay, let's do it. Okay, question 1. Prove that the square of a positive integer can never be the form 3k plus 2. Okay, so let's call the positive integer n, and then I'm going to define n as a multiple of 3, so let's call it 3a. And I'm also going to let n equal 3a plus 1, and I'm also going to let n equal 3a plus 2. And that covers all of the possible natural numbers. So it's either a multiple of 3 plus 1, or a multiple of 3 plus 2. And obviously a multiple of 3 plus 3 would be back to where we started, a multiple of 3. So this covers all of the eventualities. And then let's see what happens when we square them. So n squared in this case would be 3a all squared, which will be 9a squared. This one, n squared, would be 3a plus 1 all squared, which will give me 9a squared. I'll get a 3a and another 3a, so 6a, and I'll get a 1 times 1 is 1. And this case would give me 3a plus 2 all squared, which will give me a 9a squared. I'll get a 6a and another 6a, so 12a, and I'll get a 2 times 2, which is a 4. Okay, now can I write this in the form 3k plus 2? Well, no I can't, because I can write it as 3 lots of 3a squared, which I could say is 3 lots of some number k. So therefore that is not 3k plus 2. This one I can factorise out 3, and I can get 3a squared plus 2a close brackets plus 1. So this is the same as 3 times by a number plus 1. So again, that's not 3k plus 2. And this last one here, I can get 3a squared plus 4a. I can do plus 1 here and then plus 1 outside, because 3 times 1 is 3 plus 1 gives you the 4. And this is also 3 times a number plus 1. So we've covered all the eventualities, and the only thing we do get when we square is either a multiple of 3 or a multiple of 3 plus 1 or a multiple of 3 plus 1, but not a multiple of 3 plus 2. Question 2 is given that p is equal to log base 6 of 25 and q is equal to log base 6 of 2. Simplify each of the following logarithms given your final answer in terms of p and q. Okay, so let's see what we can do with log of 200. We can write that as log of 8 times 25. So therefore we can write that as log base 6 of 8 plus log base 6 of 25. We can write this one as log base 6 of 2 to the 3, and this one is just p. The 3 can come down to the front, and that is the same as q, so it's 3q plus p. Okay, great. Next one, log of 3.2. We can write that as log of 32 over 10. And we can write that as log of 16 over 5. And we can split that up into log 6 of 16 minus log 6 of 5. This is 16 is 2 to the power 4, And this is 25 to the power of a half. So we've got it in terms of 2 and 25 now. So we just bring down the coefficient 4, which is going to give us 4 times log base 6 of 2, so that'll be 4q. And this one, bring it down, it's going to be minus 1/2 of p. Okay, and the last one, part 3, we have log of 75, which is the same as log of 3 times 25, which is equal to log of 3 times log of 25. Sorry, plus, my mistake. Okay, now what can we do with 3? Well, 3 is the same as 6 over 2. And then we've got here plus log 25, which we know 25 is just p. And 6 over 2, that's going to be useful because we can split that up into log base 6 of 6 minus log base 6 of 2 and plus p. And of course, log of 6 in base 6 is just 1. And 2 we know is q. So minus q plus p. And I think that is done. Okay, a few ways of doing this. I mean, this is a difference of 2 squares, but I don't think that's going to help us too much because we've got this 45 on the other side. So I think the best way of doing it is just expanding the brackets. And expanding the brackets is going to give me 4 x squared. I'm going to get a 3 times 2x is 6x, then another 6x, so 12x. And I'm going to get a 3 times 3 is a 9. And then I'll put minus here. 4 times 4 is 16. I'm going to get a minus 4x, and another minus 4x makes minus 8x. And then minus x times minus x is x squared. That's equal to 45. Now, expand these out. I'm going to get 4x squared minus an x squared. So that's 3x squared. 12x minus minus 8x is 20x. 9 minus 16 is minus 7. Bring the minus 45 over to that side. So I'm going to get 3x squared plus 20x minus 52 equals 0. I can then just go straight to my calculator and go down to equation, polynomial, degree 2, 3, 20, minus 52, and I get 2 and minus 26 over 3. So x equals 2 and x equals minus 26 over 3. Okay, we have a cylinder has a radius of this and a height of that. Detailed working show that the volume. Okay, so the volume of a cylinder is pi r squared h. So this will be pi r squared is going to be 1 over root 2 minus 1 squared. And then after that we'll multiply that through by root 2 plus 1, which is the height. Okay, so let's do some work over here to see what squaring is going to do. So this will be r squared. So we're going to get 1 times 1 on top. We're going to get root 2 times root 2, which is 2. We're going to get minus a root 2. We're going to get minus another root 2. And we're going to get minus 1 times minus 1, which is just 1. So this is going to simplify down to 1 over 3 minus 2 root 2. Okay, great. So over here we can write that as 1 over 3 minus 2 root 2. And then we're multiplying by root 2 plus 1. So that can just go onto the top. Like that. Okay, great. And then we need to just rationalize that denominator. So I'll need to multiply top and bottom by 3 plus 2 root 2 over 3 plus 2 root 2. So top line, we're going to get 3 root 2, and root 2 times root 2 is 2, times by another 2 is 4. We're going to get 1 times 3, and we're going to get 1 times 2 root 2. And on the bottom, we're going to get 3 times 3 is 9. The 3 times 2 root 2, and then the 3 times minus 2 root 2 will cancel. So the only other term I need to calculate is minus 2 root 2 times 2 root 2, which is minus 4 times by 2, so that's minus 8. Okay, brilliant. So that's just 1 on the bottom, so it's just going to completely cancel. So we're going to be left with 5 root 2, and we're going to be left with 7. And yes, as required. Okay, question number 5, we've got a function and we've got another function, and we're asked to sketch the first function and show all the equation, the intersects. Okay, so I'm just going to use my graphical calculator. I'm going to sketch it, and I am then going to click V window. I want the x to start at 0. Okay, it looks like that, and then I'm going to click G-solve to find the y-intercept. That's 2. And then I'm going to press G-solve to try and find the x-intercept at the root. That's not given as a exact value, so I'm going to have to work that out myself. Okay, let's draw the graph first. And it looks like there's a asymptote. I'm going to suspect that that's at -1 because the graph is translated down by 1. To double check that, I will just go back and I will plot y equals -1. And yeah, you can see that it tends to the red line. Great, so dot 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 dot. There's the intercept at y equals -1. We got the curve coming down from here, hitting the intercept, the asymptote, sorry. That's at 2. And we're going to solve this by setting the function equal to 0. So we're going to get 3 lots of 2 to the minus x minus 1 equals 0. This is going to give us that 2 to the minus x is equal to 1, and then divide by 3, so a third. Take the reciprocal of both. We'll change the sign of the power. And then this means that x is equal to log of base 2 of 3. So this coordinate here, or this root, is log base 2 of 3. Okay, great. State the range of the function. Well, that's quite straightforward from the graph. The maximum point is 2. The minimum point is -1. That will never actually reach -1. So we need to do just a less than inequality there. Less than or equal to 2, because it can equal 2, as long as it says that, yeah, x can be 0, so that means y can be 2. Okay, great. Now we need to do f of g. So I've got to put g into f. So I would write 3 lots of 2 to the minus log base 2 of x minus 1. Okay, next I'm going to, this -1 can raise up to be the power due to log rules. So that's 3 to to the log base 2 of x to the minus 1. And then we've got 2 to the log of base 2 of something, which is very similar to having like e to the ln of something. It's just going to equal whatever that something is. So in this case, that's going to cancel down just to x to the minus 1. So we're going to get 3 lots of x to the minus 1 minus 1, and that's the same as 3 over x minus 1. Great. Question 6, we have a geometric series and the sum of the second and fourth term is 156. Well, we know that the nth term of a geometric series is ar to the n minus 1. So straight off the bat I can say that a2 plus a4 is equal to 156, which means that ar to the 1 plus ar to the 3 is equal to 156. Okay, in the same series, the sum of the third and fifth term is 234. So that means the third term plus the fifth term is 234. So that's ar squared plus ar to the 4 is equal to 234. I can notice I can take a factor out of both of these. So I can take out ar, which gives me 1 plus r squared. And over here, if I take out ar, I get 1 plus r squared. Sorry, over here I can take out r squared, which gives me 1 plus r squared inside the bracket. Perfect. Okay, let's now call this one number 1, call this one number 2, and let's do 1 divided by 2. So if I'm doing 1 divided by 2, then the brackets will cancel on the left side. ar squared divided by ar is just r. And we get 2, 3, 4 over 1, 5, 6. 2, 3, 4 divided by 1, 5, 6 is 1.5. Okay, and then next step is just to substitute into one of our equations. So let's pick this one. Seems like the most user-friendly. So we have, in fact, actually, let's just do the factorised form. It's going to make it easier to find out what a is. So a is equal to 156 over r1 plus r squared. So a is equal to 156 over 1.5 plus 1.5. So 1.5, open brackets, 1 plus 1.5 squared. So to our calculator, we do 156 over 1.5, 1 plus 1.5 squared, close brackets, 32. So there is the first term, and there is the common ratio. Okay, integration by substitution. First off, I'm going to just write this out as u is equal to 2 lots of the square root of x cubed minus 1. I'm then going to, I find it easier to get rid of the square root before differentiating. So I'm going to u plus 1 is equal to 2 root x cubed. I'm then going to square both sides, so that gives me u plus 1 squared is equal to 4 times by x cubed. And now I'm going to differentiate implicitly. So differentiating this side with respect to x, I'll first off differentiate with respect to u. So the 2 will come down, replaced by dropping the power down to 1. And the derivative of the bracket is just 1, so multiply by 1, we don't need to. But because we are doing it implicitly, I need to multiply it by du by dx. Now differentiating this with respect to x is going to give me 12x squared, like such. And then I can get an expression for dx by multiplying through by dx. Like that. And I can spot here, I've got 6x squared dx. So let's make this side 6x squared dx. And I can do that just by dividing through by 2. And then that would be really easy just to substitute in. Okay, so I think I'm ready now to substitute. Like I said before, this is a 6x squared dx. So that can just be replaced by u plus 1 du. So u plus 1 du. And on the bottom, we have the exact substitution. So that's just u. Okay, great. I can divide both terms by u. So u divided by u is 1. And 1 divided by u is just u to the minus 1. Or let's just write it as 1 over u. It makes more sense because we're integrating. And when I integrate that, I will get, well, 1 will go to u, and 1 over u will go to ln u, plus c, of course. And then my final step, I guess, because it doesn't actually say, it just says find an expression for the integral, is to just replace the u's with the substitution. So it'll be 2x to the 3 over 2 minus 1 plus ln of, make sure you put the modulus sign, 2x 3 over 2 minus 1 plus c. Just a final point, we could do a constant swap here, because we have a constant in minus 1 plus an arbitrary constant, so we could just replace that with another different arbitrary constant. So we could simplify it slightly by writing it like this, and let's call this new arbitrary constant k. Either would be fine. Okay, question 8. We have a sector, general sector, and it says that the area of the minor sector is 48, so that's 48 in there, and the length of the minor arc is 12. It then says determine the value of r and theta. Okay. So the area for a sector, the area of a sector is a half r squared theta. So in this case, that will be equal to 48. So we'll say a half r squared theta is equal to 48, and the minor arc, well, the area, the arc length is equal to r theta. So in this case, 12 is equal to r theta. Okay, so this looks like a simultaneous equation we'll have to solve by dividing. So we'll take 1, we'll take 2, and we'll do 1 divided by 2. So we'll get a half, and then we'll get r squared divided by r, which is just r. We'll get theta divided by theta, which will cancel, and we'll get 48 divided by 12, which is 4. Okay, great. This gives me that r is 8. and then just using equation number 2, we're going to get that 12 is equal to 8 theta, so theta is equal to 12 over 8, or 3 over 2. Okay, differentiation from first principles. We're going to need to know the formula, which is that f dash of x is equal to the limit of, as h tends to 0, of f x plus h minus f of x all over h. So let's just sub in. So the function with the x replaced with x plus h's is 1 over x plus h squared minus 2 lots of x plus h, and then we're subtracting just the function itself, so 1 over x squared minus 2x, and we're dividing that all by h. I'm just going to write divide by h here because I don't want to create a fraction in a fraction, if you see what I mean. Right, we're going to have to try and simplify this as much as possible, so we have to expand and cross multiply. I'm going to try and do it in as few steps as possible. So cross multiplying, top left will be x squared minus 2x, top right will be minus, and then just this lot here, which I'm going to expand at the same time. I'm going to get an x squared, I'm going to get an xh and an xh, so a 2xh and an h squared. I'm also going to take away 2x and 2h, and that's going to be all over the two of these multiplied together to get a common denominator. So I would do that by writing out this as it is here, x squared plus 2xh minus 2x minus 2h, and we're cross multiplying that, so we're multiplying it by the other denominator, which is x squared minus 2x, and remember this is all divided by h as well at some point. Okay, great. Let's now do some cancelling. So we've got x squared minus x squared, we've got minus 2x minus 2x, and we can also divide through by h as well. So dividing through by h means I just need to divide the numerator by h. If I divided both, then I wouldn't essentially be dividing by anything, I'd be dividing by 1. So just the numerator, so that cancels, that turns into just a h, and this cancels as well, and this will simplify to, we've got a minus 2x, we've got minus h, and we've got minus a minus 2, so plus 2. And along the bottom we've got this x squared plus 2xh plus h squared minus 2x minus 2h multiplied by x squared minus 2x. And what I've forgotten to do is write every time limit as h tends to 0, limit as h tends to 0, limit as h tends to 0. So now I can actually let the limit tend to 0, and that will knock out any term that has a h in it, like such. So that will leave me with minus 2x plus 2 all over x squared minus 2x in this bracket, and you'll notice it's exactly the same as this bracket, so just squared. And we're done. Okay, question 10, we've got an implicit equation and we're asked to work out the stationary points. Could use quotient rule here, but that's just nasty, don't want to do that, so instead I'm going to multiply the equation through by y first. This will give me 3x squared minus 5y squared is equal to 2x, I multiply the brackets but then times by a y, and 2 times 8 is 16 and times by y. Okay, let's differentiate this function. 2 comes down, times by the 3 gives me 6, drop the power down by 1 to make 1. If I'm differentiating with respect to x a function of y, like so, then what I would do is I would differentiate implicitly, which means differentiating with respect to y, which will be more easy to do, and then multiplying it through by dy by dx, and you'll see here that the dy's on the bottom will cancel, so this equation is now equal. So differentiating it with respect to y is going to give me 10y, and then I just have to times it by dy by dx. This is a product, so I'm going to differentiate this bit first, and that's going to give me 2, and I'm going to keep the y the same. And then I'm going to keep the 2x the same, and I'm going to differentiate the y to get dy by dx. And 16y differentiates to 16 times by dy by dx. It hasn't actually asked me to find an expression for dy by dx, so I don't need to collect up all the dy by dx's and then factorize and then divide. Instead, I can just find the stationary point by setting dy by dx equal to 0 in this form. And when I do that, then these will just go to 0, which means I'll be left with 6x is equal to 2y, so 3x is equal to y. So when there's a stationary point, the x coordinate times 3 is equal to the y coordinate, and we can find those specifically on the curve by subbing it back into the curve. So I'm going to get 3x squared, and I'm going to replace the y with a 3x. Place the y with a 3x, and multiply out these brackets. This is going to give me 1x minus 15x is minus 14x. So minus 16x is equal to 16, so x is equal to minus 1, and the y value is 3 times the x, so y is equal to minus 3. Okay, question 11, we've got a differential equation, and it is k is a positive constant, t is measured in days. We know that initially the population is p0. Solve the differential equation to find p in terms of p0, k, and t. So we need to separate the variables. So first thing I would do will be to multiply both sides by dt. Like this. I need to move the p over to the left hand side, so I get 1 over p dp is equal to k cos kt dt. And I'll keep the k on the right side because I can see that it's going to be very useful when integrating cosine kt. Okay, right, time to integrate both sides. This is going to give me ln p, and cosine integrates to sine, and the derivative of the input will be k, so we divide by the derivative of the input, and then dividing by k will cancel out this k here. So this is going to integrate just to sine kt, plus a constant, of course. Okay. Next step would be to let's take e to both sides. Apologies for the pause. Let's make e the base of both sides. And then what we can do is, well, this e to the ln will just be p, and this will be the same as e to the sine kt multiplied by e to the c, and we can do a constant swap there and call e to the c just a. So this means we get a e to the sine kt. Okay, and now we can sub in our initial conditions. and we get that P naught is equal to P when t is 0, and when t is 0, sine of kt will be sine of 0, which will be 0, so it'll just be e to the 0, which is 1, so it'll just be, so the arbitrary constant a is equal to p naught. So therefore my final solution will be that p is equal to p naught e to the sine kt. Okay, great. Now it says the value of k is now assumed to be 3. So calculate the correct nearest minute, the time for the population to reach p naught again for the first time since t naught is equal to 0. Okay, so you want the population to be p naught, and we know that we have k is 3. So dividing through by p naught gives me 1 is equal to e to the sine 3t. Next we can take ln of both sides. So this gives me 0, and this gives me sine 3t. Okay, so solving this equation, we will take the inverse sine of 0, and of course that happens at 0, and it also happens at pi, and it also happens at 2 pi. So that will be equal to 3t. We know already there's a solution at 0, and the first one after is pi. So this is the one we're interested in. So we're going to get that t is equal to pi over 3. And we're going to need to calculate that because it needs it in a decimal. And remember that t is given in days. So we do pi over 3 equals, don't know it off by heart, I'm sorry to say, 1.047. That's the number of days, because t was measured in days, and it asked us for in minutes, so we're going to need to multiply that through by 24 to get the number of hours, and then we need to multiply that through by 60 to get the number of minutes. So 1508. Okay, we've got parametric equations, and it's asking us to show with detail working dy by dx. Okay, so I'm going to differentiate using the quotient rule. First off, dy by dt. So we always start with v, which is the denominator, multiplied by the derivative of the numerator, which is 0, minus u, which is the numerator, multiplied by the derivative of the denominator, which is just 1. And that's all over the v squared, so the denominator squared. Okay, great. So that gives me just minus 2 on top over t plus 2 cubed, squared, sorry. Now I need to do the same, differentiate the x with respect to t. So I'm going to use quotient rule again. Always start with v, which is the denominator, times by the derivative of the numerator, which is 1, minus the numerator, multiplied by the derivative of the denominator, which is 1, all over the denominator squared. This is going to simplify. We're going to get t plus 1 minus t minus 3. So the t minus t will cancel and you'll get 1 minus 3, so you get minus 2. Okay, smashing. So dy by dx is equal to dy by dt divided by dx by dt. So this is going to be minus 2 over this divided by minus 2 over this. And grabbing a bit more space, we're going to have minus 2 divided by minus 2. So that cancels. This is going to come to the top, and this is going to drop down to the bottom. So we're going to end up with dy by dx is equal to t plus 1 squared over t plus 2 squared, and that's the same as t plus 1 over t plus 2 all squared, because when you distribute a square into a fraction, you just square the top and you square the bottom. Okay, great. And now it says find the Cartesian equation of the curve. So part B, let's just have a look at what the ones were again. So we want it to be y equals. So I'm going to make t the subject of this equation, then I'm going to replace it in here to get a y equals. It might not be the most efficient method, but it's just going to work, so I'm going to do it. X, t plus 1, t plus 3, so that's just multiplying up. And then I'm going to expand and I'm going to collect all of the t's on one side, like so. Factorize and then divide. Okay, great, that gives me t as the subject, and then I'm going to replace it in the y equation, which is 2 over t plus 2. So y is equal to 2 over t plus 2, but that's the same as 3 minus x over x minus 1 plus 2. Okay, and then let's multiply top and bottom by x minus 1. So that will give me y is equal to 2 lots of x minus 1 over 3 minus x plus 2 lots of x minus 1, and then we just expand to get 2x minus 2 over, on the bottom we're going to have minus an x plus 2x, which is just 1x. We're going to have a 3 plus, or 3 minus 2, so that's just plus 1. And then we can take out a factor of 2, like so, and I think that is what we require. Yes, it is. Marvellous. Okay, question 13, we are asked to find the gradient of the curve g f of x at the point where x equals e. So first thing we're going to do is find the function g f of x, which means putting f into g. So I'm going to write out y equals, and I'm going to write out g, but I'm going to replace the x with 3 ln 2x. So it's going to be 2 lots of 3 ln 2x squared plus 1. Okay, that's good. And then we need to differentiate this. So dy by dx. So I've got a bracket here. I'm going to bring the 2 down and multiply it by the 2 to get 4. And I'm going to keep the bracket the same. And I'm going to drop the power down by 1. but I'm going to need to multiply by the derivative of the bracket. So what is the derivative of 3 ln 2x? Well, this is the same as the derivative of, we can split up this ln into 3 ln of 2 and 3 ln of x. And ln of 2 is just a constant, so that will differentiate to 0. And we know that 3 ln x differentiates to 3 over x. So the derivative is just 3 over x. So I need to multiply by 3 over x. And 1, of course, differentiates to 0. Okay, and now we need to just sub in the point where x is equal to e. So I'm going to put the derivative at the point e is equal to 4 3 ln of 2e times by 3 over e. Okay. Again, what we could do is we can split up this. So ln of 2e is equal to ln of 2 plus ln of e. And what about the numbers here? We're going to have 4 times a 3 times a 3, so that's 36. And we're going to have ln of 2 plus ln of e, and that's all going to be over e because of this. So that's the same as 36 over e, and this ln of e, well, ln and e cancel, that simplifies to 1, so that's where we get our 1 from, and that's where we get our ln 2 from. Okay, question 14, integrate this. It looks like a partial fraction here, so we're going to have to write 3x minus 5 over x minus 1 is equal to a over x plus b over x minus 1. We're then going to multiply up by the denominator to get a lots of x minus 1 plus b lots of x. We're then going to let x equal 1, and that will give me 3 minus 5 is minus 2. The a bracket will cancel because that's 0, and 1 times b is just b, so b equals minus 2. And then we're going to let x equal 0. 3 times 0 minus 5 is minus 5. And a times 0 minus 1 is just minus a, so a equals 5. Okay, so now we are integrating between 2k and k this new split up fraction where a is 5, so 5 over x, and b is minus 2, so I can put the minus there, and 2 over x minus 1 dx, and we're told that's equal to ln of 72. Okay, so let's integrate that. So first off, we know that 1 over x integrates to ln x, so 5 lots of that is 5 ln x. And if the denominator's derivative is the numerator, then we're going to get a ln. And here the derivative of x minus 1 is 1, so we're going to get 2 lots of, or minus 2 lots of ln x minus 1. And that's equal to ln of 72 when I put in the constants, or the limits, sorry, 2k and k. Okay, great. Right, let's now actually sub in those limits. So I'm going to get 5 lots of ln 2k minus 2 lots of ln 2k minus 1, and I'm then going to be subtracting, this is looking horrible already, 5 lots of ln k minus 2 lots of ln k minus 1. Okay. Right, let's sorry, I didn't put the modulus signs in here, which is a bit naughty, but probably get away with it. Okay, so let's pair up then, because we've got this and we've got this, which is going to be really helpful. So and let's have 5 lots of ln 2k minus 5 lots of ln k is the same as 5 lots of ln 2k over k. And then let's pair these ones up as well. So that's a minus and a minus. So that's going to be positive. So we're going to get 2 lots of ln of k minus 1 over 2 lots of, again, ln 2k minus 1. Because we've got a positive here and a negative there, so we can divide the lns, and both of them have a factor of 2, which we can just take out. And that's equal to ln of 72. Okay, so what is this? This is 5 ln of 2. So we can move that over to the other side. So we have 2 ln k minus 1 over 2k minus 1 is equal to ln of 72 minus 5 ln 2. And 5 ln 2 is the same as ln 2 to the 5, which is the same as ln of 32. So this is going to give me ln 72 minus ln 32, which is the same as ln of 72 over 32. And I'll just quickly do that. 72 over 32 is 9 over 4, which is helpful. Those are both square numbers. I'm pretty sure that will be useful. Yes, it is, because we can write 3 over 2 to the power 2. And then we can bring that 2 down to the front, like this. And that's going to be helpful, so we can just divide through by 2. And now we've just got ln and ln on both sides, so therefore their inputs must be equal. So we get k minus 1 over 2k minus 1 is equal to 3 over 2. And then we just need to solve for k, don't we? So multiplying both sides by 2 and multiplying both sides by 2k minus 1 gives me this. And then we get 1 is equal to 4k, k is equal to 1/4. Good job. Okay, question 15, we've got 4 points there, and it's asking us to use vector algebra to show that 3 of the above 4 points are collinear, which means they lie on a straight line. So let's imagine we had A, and we had B, and we had C. If they were collinear, they would all lie on the straight line, and it means that A to B would be a multiple of A to C, which would also be a multiple of B to C. But essentially, you need to show that some of these vectors are multiples of one another. So let's just start with assuming that A is on the line, and let's work out what A to B is. Well, that's the same as OB minus OA, which is equal to 0 minus 5, 10, minus 2 minus 1, 4. And here we get minus 2, minus 4, and 6. And then we will try A to C, which is OC minus OA. So this is 3, 1, 3, minus 2, minus 1, 4. And this is going to give me 1, 2, and minus 1. Those are not multiples of one another, so we're going to have to go again and try A to D and hope that this is good. Otherwise we'd have to conclude that A is not on the line. So this is 6, 7, minus 8, minus, again, 2, minus 1, 4. And this is going to give me 4, 8, and minus 12. And that is a multiple of AB. So we can say here that that AD is equal to, what is it, minus 2 times by AB. Yeah, just checking that works. Okay, so therefore A, B, D are co-linear. Okay, next part, we've got a triangle drawn with 3 of the above 4 vertices, and given that the triangle has the largest possible area, determine the, this is a fantastic question. So we know that A, B, and D are on a straight line. So let's put A here, and it says that A to, let's say A to B is going, let's say it's like going that way, so there's B there. Then A to D, we know is minus 2 times A to B. So it's 2 times bigger, and it's in the negative direction. So it's in the opposite direction. So it looks like this. And then there's going to be some other point C somewhere, like this. So the largest triangle I can draw is going to be A and D. It's going to be AD and, sorry, it's going to be DCB. That's the largest triangle you could possibly draw connecting up those points. Okay, so let's work out the shortest side. So let's first look at B to D. Well, we know that B to D, let's say this is yeah, so B to D is the same as B to A plus A to D, which is minus AB plus AD. Which we already have some of these things, so it's going to be minus AB is 2, 4, minus 6, plus AD is 4, 8, minus 12. So this is going to give us 6, 12, minus 18. So the modulus of B to D is equal to the square root of 6 squared plus 12 squared plus 18 squared, which we could do on our calculator. So that is 6 squared plus 12 squared plus 18 squared, and we get 6 root 14. We grab some more space. Okay, we're also going to need to find D to C, which is of course OC minus OD, which is 313. minus 6, 7, minus 8. So that's equal to minus 3, minus 6, and 11. And then we'll take the modulus of DC. And that will equal, see, the square root of 3 squared plus 6 squared plus 11 squared. Which gives us root 166. And then finally, b to c. Do we have that one already? No, we don't. Ugh. Log OC minus OB. So that's 313 minus 0 minus 510. So this gives me 3, 6 minus 7. So b to c modulus is the square root of 3 squared plus 6 squared plus 7 squared, which is definitely going to be smaller than this one. In fact, it's very similar, so I could just change this. Whoops. Root 94. 36 times 14 is definitely bigger than 94, so this is our final answer. Wow, that was a beast question. Oh, this question is fantastic. It's quite tricky. We know that arc cos of a value is going to give us an angle, so let's just call that angle here theta. And we know that again arc cos of a value is going to give us an angle, let's call that angle phi. And this is actually a show that question, so I don't really want to use this in my working. I want to arrive at that answer. So at the moment I've just got theta plus phi, and that's going to equal some value. So let's just call it x. I don't want to assume that it's 3 pi over 4 just yet. And then what I can do is I can take the cosine of both sides. And that's going to be useful because obviously we've got arc cosine here, so I'm hoping that we're going to get some cancellation. Okay, now what is, let's write it the other way around. What is the cosine of a compound angle like this? Well, we know that it's going to be cosine theta times cosine phi minus sine theta sine phi. And what is cosine theta? Well, we've already determined that theta is arc cosine of 5 to the minus a half. So cosine theta will be cosine of arc cosine of 5 to the minus a half. And cosine arc cosine will cancel. So we know that cosine theta is just 5 to the minus half. So I can write here that cos x is equal to 5 to the minus half, which is the same as 1 over root 5, multiplied by cosine phi. By the same token, it's just going to be 10 to the minus a half, which is 1 over root 10. And how are we going to work out sine theta? Well, if I know what cosine theta is, I instantly could work out sine theta by drawing a right angle triangle, putting the angle in here. Cosine theta is 1 over root 5, which is the adjacent over the hypotenuse. So by doing Pythagoras' theorem, squaring root 5 gives me 5, minus 1 squared is 4, square rooted is 2. So therefore sine theta is 2 over root 5, because it's obviously the adjacent over the hypotenuse. And we could do the same thing for phi as well. Again, draw a right angle triangle, put the angle in there. We know that the cosine of phi is 1 over root 10. 10 squared root 10 squared is 10, minus 1 squared is 9, rooted is 3. So sine is the opposite over the hypotenuse, so that's 3 over root 10. Okay, we can then do some multiplying. Both of these two will have a fraction, a denominator of root 50. And we're going to have 1 times 1, and then we're going to minus 2 times 3, so that's going to be minus 5. Root 50 is the same as root 25 root 2, so it's 5 root 2. So this is the same as minus 1 over root 2. Okay, great. So we got that cosine x is equal to minus 1 over root 2. And we can just go to our calculator and we can do shift cosine of minus 1 over root 2, and we get 3 pi over 4. So x is equal to 3 pi over 4, and that is proved. Okay, we have a rectangle, it has 3 vertices, A, B and C. Show that blah 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 blah, hence determine the 2 possible values of k. Okay, so first off, let's draw a picture, because it says A, B, C, D, which means it has to have vertices going around in this order. We don't know what D is, but we do know that A, B and B, C are perpendicular. So the gradient of AB, which we can get by doing, we can do that by doing 10 minus k, so the change in the y's, 10 and k, over the change in the x's, 5 and 3, is 2, must equal the negative reciprocal of b to c. So it's the negative reciprocal, so I'm going to do the change in the x over the change in the y. And the change in the x from b to c is, let's do it this way, so I get 2 minus k like it says here. So 9 minus 3 is 6, and 2 minus k is 2 minus k. Okay, great. So let's multiply through then. We're going to get 10 minus k is equal to times by 2 and minus times by 2 and the minus going to give you minus 12 over 2 minus k, and then multiply that over to that side, and that should give you what we require. Oh, it says plus 12, so just, yeah, move that over to make it plus 12 equals 0. Okay, great. Then find the 2 possible values of k. Well, let's expand this out to get a quadratic, then solve the quadratic. So 20 minus 2k minus 10k plus k squared plus 12 equals 0. So k squared minus 12k plus 32 equals 0. 8 and 4, so k minus 4, k minus 8 equals 0. So k equals 4, k equals 8. It is further given that the rectangle reduces to a square for one of the 2 values of k found in part A. For the square, find its area. Okay. This is Okay, so let's let's just assume that k equals 4. Try that. And if k was equal to 4, the distance from A to B would be the change in the x's, which will be 2, and the change in the y's, which will be 6. So it'll be 2 squared plus 6 squared, square rooted. And let's do b to c. B to c, the change in the x's will be 6, so it'll be 6 squared, and the change in the y's will be 4 to 2, which will be 2. So that would work. They would give you the same distance. So k must be 4. And the area will be these two surds times together. So we have k equals to 4. Area is equal to the square root of this multiplied by obviously itself, so that's just the square root of 40 times the square root of 40, which is 40. And then the coordinates of D. Okay, so we can see that B changes to C by going from 3 to 9, so plus 6 in the x, and the y goes from 4 to 2, so minus 2. So A to D would be the same, so we need to plus 6 to the x, which gives us 11, and then minus 2 to the y, which gives us 8. So D would be 11, 8. Okay, a relatively straightforward question, this one. You've got a cubic and it has 2 turning points, a maximum and a minimum. So we're going to differentiate, and that will give me 3ax squared plus 2bx plus c. And we know that if the gradient is 0, then we get stationary points, and we want 2 distinct stationary points. So therefore this quadratic will have 2 roots. So if its quadratic has 2 roots, then we know that the discriminant is greater than 0. And the discriminant is the b squared. In this case, the b term is 2b. So 2b squared minus 4 times a term, which is the term multiplied by the x squared, which is 3a. So minus 4, 3a, and then multiplied by the c term, which is c. And that needs to be greater than 0. So that's 4b squared minus 12ac is greater than 0. Divide through by 4 gives me this. And then finally b squared is greater than 3ac. QED. Okay, question 19, we have a circle and it says a straight line t is tangent to the circle at that particular point. Find an equation of t. Okay, so first off what we're going to need to do is write that circle in completed the square form. So we're going to have x minus 2, because the x term is minus 4 there, squared, and then minus 2 squared is 4, so we take away 4. And then the y's, we're going to have plus y minus 3, because that's half of the minus 6 squared. Minus 3 squared is 9, so we take away 9. And we've also got to add on 8, and that's equal to 0. Okay, so this gives me x minus 2 squared plus y minus 3 squared. Minus 4 minus 9 is minus 13, plus 8 is minus 5, so that equals 5. So what does this tell us? Well, it tells us that the centre of the circle is at x is equal to 2, y is equal to 3, and it also tells us that the radius is equal to root 5. Okay, now we know also that there is a tangent at a particular point, 4, 4. So what I can do is just a quick sketch of the circle. It will look something like this, and we'll have a centre here at 2, 3, and we'll have this point over here at 4, 4. And this is where the tangent is. So what we're going to do is we're going to work out this red line first. So the red line, or the gradient of the red line should I say, so the gradient of the red line, let's do it in red, is equal to the change in the y's, so 4 minus 3, over the change in the x's, so 4 minus 2. So that's equal to 1 over 2, so half. So that means the gradient of the purple line is the negative reciprocal, because tangents and radius meet at 90 degrees. So the gradient of the purple line is minus 2. And then what we can do is we can do y minus y1 equals mx minus x1 for the equation of a straight line. And we know the tangent goes through 4, 4, so we can do y minus 4 is equal to the gradient minus 2, x minus 4. And then we can multiply out these brackets to get minus 2x over here. We'll get plus 8, and then plus the 4 as well, so plus 12. Okay, next point, it says the tangent T1 passes through this particular point to 8. The straight line T2 is tangent to the circle and also passes through Q. Determine the points R and the equation of T2. So we've now got to draw on a second tangent like that, and they meet at the point 2, 8, and the point where the tangent meets the circle is the point R, which we need to calculate. What you can notice is that the centre and the tip of the hat, as you could call it, is directly below, because they both have an x-coordinate of 2. So by symmetry I could draw a line across like that, which will be perfectly at right angles. So I can just by inspection see that it's 2 along the x to get to the centre, so it'll be 2 along the x to get to R. So 4, 2 and 0. So the R coordinate is 0 in the x, and the y coordinate must be the same over here, because again it's at right angles to this vertically orange line there, so that will be 4. Okay, and next it asks us to work out the equation of T2. Well, we've got 2 points on the green line. We've got R and we've also got 2, 8. So we can go through the process of finding the gradient. And this will be 8 minus 4 over 2 minus 0. So it will be 4 over 2, which is just 2. And then we'll do y, oh actually we don't need to do that. We can see that the y-intercept is 0, 4. So we can just say y is equal to 2x plus 4. Okay, question 20. We've got sine p plus sine q, and we've got it equal to 2 lots of sine p plus q over 2 cos p minus q over 2, and it gives us a hint that we have to use the compound angle formula. Okay, so let's just remind ourselves what each of these are. So sine a plus b is the same as sine a cos b plus cos a sine b, and the only difference if we have a minus sign between them is that we just have a minus sign right here. Okay, so we've got two sine functions added together, and I can see here it's going to give me two lots of sine cos. So if we add these two together, we're going to get two sine functions added together on the left side. And on the right side, we're going to get two lots of sine something cos something. So that's promising. Now I think what we need to do is just substitute. So the first thing is p, and here we've got a plus b. So let's just let p equal a plus b, and then let's let q equal a minus b. And this will then give me it will give me sine of p plus sine of q, which is what we want. Over this side, I need to let's see what will happen if we add these two together, because that will give us this p plus q, which is quite useful. We're going to get p plus q, and that will equal a plus a, so 2a. So this gives me p plus q over 2 is the same as a. Okay, that's great, because that can go in here. 2 sine a, we've just proved, is p plus q over 2. And then finally, how are we going to get b? Well, we're going to subtract these two equations. So let's see what happens when we subtract them. We'll get p minus q is equal to, the a's will cancel, and we've got b minus minus b, so 2b. So it's nice and clear that we're going to get, this is b. So I can finish off by writing that cos p minus q over 2. Kind of run out of space there, but that looks to me like we've proved it. Okay, part B says, hence or otherwise solve the trig equation 7x plus x equals 0. Hence or otherwise, I think it's much easier to use the hence. So, yeah, we've got sine p plus sine q. So here we're going to have sine 7 plus sine 1. So essentially we are setting p equal to 7x and q equal to 1x. So we say p is equal to 7x, q is equal to 1x, and that means that our equation equals to 0 transforms into the right hand side, which will be 2 sine of p plus q over 2. So 7x plus 1x is 8x, divided by 2 is 4x, multiplied by cos p minus q over 2. So that's 7 minus 1x, 7x minus 1x is 6x, over 2 is 3x. Okay, so how is this equation going to equal 0? Two ways. Either sine 4x equals 0, or cos 3x equals 0. Okay, let me just grab some more space. So sine 4x equals 0 or cos 3x equals 0. If sine 4x equals 0, then it means that 4x is equal to, well, sine of 0 is 0, and the next time that sine is 0 is pi, and then after that is 2 pi. Just go double check what the range is. It's between 0 to 0 to pi. So when I've got a 4x, I'll need to up that to 4 pi, not including pi. Okay, so we can also go to the next one, which will be 3 pi, but 4 pi is too far. And then for cos 3x, when does cos equal 0? Well, that would be pi over 2, and then 3 pi over 2. And how far do we have to go? Well, if the input is 3x, then I'll need to go to 3 pi. The next one along is 5 pi over 2. And then after that, we're going to get 7 pi over 2, which is too far. So then we just divide through by 4, so I get 0, pi over 4, pi over 2, and 3 pi over 4. Then dividing through by 3 gives me pi over 6. It gives me pi over 2. And it gives me 5 pi over 6. So all in all, because we've got pi over 2 twice, we'd want to write them out in order. Would be 0, pi over 6, pi over 4, pi over 2, 3 pi over 4, and 5 pi over 6. Okay, we've got a binomial expansion. It says the x coefficient is minus 6 and the x squared coefficient is 27. It says show that b is equal to 3 and find the value of n. Okay, so the expansion that we are given is that this binomial will equal 1 plus n multiplied by the x term plus n minus 1 times by the x term squared, and that's all over 2 factorial, which is just 2. Okay, so we don't need to go any higher than that because we know that the x coefficient is 6, so that means that this part here is going to be 6x, which means that nb is equal to, sorry, it could be minus 6, so nb is equal to minus 6, and from this one here we know this is going to be 27, so this is going to be 1/2 n minus 1 b squared, and I'm going to get b squared x squared, but we don't need to put that because we're just looking at the coefficient, and that's going to equal 27. Okay, I think the best way to solve this is to substitute in for b. So I'm going to make b the subject over here, square both sides to get 36 over n squared, and then replace over here 1/2 n minus 1, and this is going to be 36 over n squared is equal to 27. Okay, we will multiply both sides by 2, so that will give me 54, and I will multiply out these brackets to get n squared minus n, and that's still times by 36 over n squared, and then multiply out through these brackets as well. 36, n squared over n squared will cancel, so that will just be 36, and this will give you minus 36 over n. Okay, this is going to give me minus 18 on this side when I move the 54 over, and I push that over to that side, it's going to give me this, and therefore when we multiply up and then divide through, we're going to get n is equal to minus 2. Okay, then going back over to this side, I know that b is equal to minus 6 over n, so b is equal to minus 6 over minus 2, so b is equal to 3 as required. It then says find the x cubed coefficient. Okay, so I've got to carry on this expansion. It'll be n minus 1, n minus 2, bx cubed all over 3 factorial, which is 6. Okay, so this is a calculator jobby really. You know that n is minus 2. Multiplied by minus 3, multiplied by minus 4, and then multiplied by b, which was 3 cubed, so 27, and then we're going to divide that by 6. So we get minus 108. It's just the answer to that one. And then state the range of values for which the above expansion is valid. Well, this is this part here, that the modulus of bx must be less than 1. So that's the modulus of b we were told was 3. So 3x is less than 1. So that means that the modulus of x is less than 1/3. And if that's the case, then it means that x must be in between minus 1/3 and 1/3. Okay, we have we need to integrate this and find the area basically. So there's a couple of ways of doing this, but I'm going to try and do it using only A-level pure techniques and not further maths. So I'm first going to find these intersection points. Let's find this one right here. So when y equals 1, we're going to have 1 is equal to the cube root of 8x minus 27, which means I'm going to get 1 is equal to 8x minus 27. So 28 is equal to 8x. So x is equal to 28 over 8, which is 7 over 2. Okay, so this down here is 7 over 2. I'm also going to want to find this point here, where y is 0. So when y is 0, we will get the cube root of 8x minus 27 is 0. Which means that 0 is equal to 8x minus 27. So 27 is equal to 8x. So x is equal to 27 over 8. So that is 27 over 8 right there. Okay, and then what I'm going to do is I'm going to integrate between these 2 points to get this blue area here. That's going to be very helpful. So let's do that. I'm going to integrate between 7 over 2 and 27 over 8. And the function is 8x minus 27 to the third. So when I integrate that, I will up the power, and that turns it to 4 over 3. Keep the bracket the same. Divide by the new power, and also divide by the derivative of the bracket. So I need to do 1 divided by 4 over 3, and then divided by the derivative of the bracket, which is 8. So I'm going to get 3 over 32. Like that, and that is between 7 over 2 and 27 over 8. Okay, when I input 7 over 2, I get 3 and I get 3 over 32. And when I input 27 over 8, I get 0. So this is going to be 3 over 32. So this blue area in here is 3 over 32. And we know we can then work out the yellow area while we're here, because the yellow area will be this rectangle minus 3 over 32. So the rectangle will be 1 times 7 over 2. And then we need to subtract off the blue area, so minus 3 over 32. Okay, we'll leave it like that for now because I want to use my calculator to work out the next part, where we integrate between 0 and 27 over 8. So I will be integrating the same function, so I'll get the same output, but now I want to do it between 27 over 8 and 0. Well, we know what we get when we sub in 27 over 8, we get 0. And when we sub in 0, we can do that now, and we will get 243 over 32. So this is a negative answer, as we would expect, because it's below the axis. Okay, so now let's bring it all together. It means this actual positive area will be 243 over 32. And we need to add that onto the yellow area. So in total, we are going to have this plus 7 over 2, and then minus 3 over 32, which equals 11, as required. Okay, maybe not the most efficient way of doing it. You can integrate with respect to y instead, which will be quicker, but I wanted to use just methods which are only in A-level pure for all the common exam boards. Question, you need to differentiate arcsine 2y, which in EDEXCEL now you don't need to do this, but you will need to do something similar, which is just taking sine of both sides, which will give me sine y is equal to 2x. So you are asked to differentiate that, which we can do now. I can differentiate with respect to y. Differentiating with respect to y is going to give me cos y, and if I want to differentiate 2x with respect to y, then I'll differentiate it with respect to x, but then multiply it by dx by dy, so that this cancels with that and we get equality on both sides. So that's going to give me two lots of dx by dy. So therefore dx by dy, which is what we've been asked to find, is equal to cos y over 2. Okay, and now we need to flip it and then use a trig identity to get it in terms of x. So by flip it, I mean I want to write dy by dx now is equal to 2 over cos y. Okay, yep. And I know over here, using this one, sine y is equal to 2x. It's asking me to use a trig identity, so I could use a triangle here, but instead I'm going to use a trig identity, which is obviously sine squared y is equal to 4x squared. So therefore, sine squared we know is 1 minus cos squared. I'm not sure why I put that in brackets. Rearranging to get cos squared, that's going to give me cos squared y is equal to 1 minus 4x squared. So therefore cos y is equal to the root of 1 minus 4x squared. So we can finish it off by substituting into here to get dy by dx is equal to 2 over the square root of 1 minus 4x squared. Okay, next it's asked us to differentiate that again, and then differentiate it again. Okay, so we could use the quotient rule, but I don't think that's going to give us what we want, because it's not going to give us a power of 3 over 2 on the bottom. In fact, it will give us v squared on the bottom, which will be just 1 minus 4x squared. Okay, so differentiating this, first I'm going to write it as a power, the bracket as a power, so 1 minus 4x squared to the power of minus a half. Then just going to use the chain rule, so I'm going to bring the power down, and that's going to give me minus 1. I'm going to keep the bracket the same. I'm going to drop the power down by 1, and then I'm going to multiply by the derivative of the bracket, which is minus 8x. And this will be the second derivative after I've differentiated like I just did. And we're going to get the minus and the minus cancelling. This bracket is a negative power, so that's going to be on the bottom. The 8x is not negative, so that will be on the top. So 1 minus 4x squared on the bottom, and the power is 3 over 2. And I believe that is as required. Looks good to be. Yep, so a is equal to 8. Okay, now we've got to differentiate this again, which is not going to be pretty. We're going to use the quotient rule, so I'm going to set u is equal to a to x, and v is equal to 1 minus 4x squared to the 3 over 2. We're going to differentiate this to get a. So give me v dash is equal to 3 over 2, 1 minus 4x squared, drop the power down, and then multiply by the derivative of the bracket. Okay, we're then going to use the quotient rule. And I'm going to do a cheeky little substitution, because this is just going to be too nasty. I'm going to say that this is equal to, let's go with y. So therefore this is equal to y cubed. Okay, let's see how this works. I'm confident it will. We start with v, so v is y cubed, and we've got 8 here, so we've got 8y cubed. And then we're minusing these two multiplied together, which will be actually a plus because we've got a minus here. 8x times 8x is 64x squared. And then we've also got to times that by 3 over 2, so that's 32, so that's 96. And then this just is y. And that's all over v squared, and we know that v is y cubed, so that's going to be y to the 6. Okay, great. Right, that's much easier to deal with. We can spot that there is a factor of 8 on the top. Oh, in fact, actually, we could divide through by y first. So we get y squared, and this gives me 96x squared, and that's all over y to the power of 5. Okay, I can take out an 8 from the top, and I think that is about as good of a job as we could do. So let's substitute back in. Okay, so y squared is just 1 minus 4x squared. So we're going to get 8, 1 minus 4x squared, and then plus 12x squared. And on the bottom, y to the power 5 is just this to the power of 5 over 2. Okay, so to finish off, this is going to be 8 lots of 1 and then plus 8x squared all over 1 minus 4x squared to the 5 over 2. Okay, great. They haven't taken a factor out of the top, so I just need to expand the 8, and that will give me b and c. So expanding the 8 out is going to give me 8 as c and 64 as b. So b equals 64, c equals 8. Great. Oh, I think that worked really well. Chuffed with that. Okay, final question. Right, let's solve it. E to the 2 minus e to the 3x minus 1. Can't do anything fancy there. We're dividing e's here, which means we can subtract the powers. So that's going to give me e to the 3x plus 1, which is then squared. And when we square, it means we can multiply it through the powers. So I get e to the minus 2, e to the minus 3, sorry, e to the 2 minus e to the 3x minus 1 is equal to e to the 6x plus 2. Okay. Okay, this e to the 2 is really annoying, so let's see if we can't do something about that. Let's bring over the e to the 6x plus 2. And then let's move everything over to the other side like that. Because this can be written as e to the 2 minus e to the 2 times e to the 6x, because when we multiply e's, we just add the powers. So that's correct, and that's going to be useful because we can then take out a factor of this e to the 2, which is going to give me this. Okay, now the key trick to this question is spotting that this is a difference of two squares. And it is a difference of two squares. We know this because 1 is obviously a square number, and anything to an even power is a square. So we can split this up. So we can write e squared, 1 minus e to the 3x, times by 1 plus e to the 3x, and that's equal to e to the 3x plus 1. Okay, great. And then what we could do is we could divide through by 1 plus e to the 3x. And that's perfectly fine to do because that can never be 0, because 1's obviously positive and e to the 3x is also positive. So that will give us this is equal to 1. Okay, and now that we've just got a single x in our equation, we can just solve it by rearranging for x. So I can divide both sides by e to the 2, and that's going to give me e to the minus 2, and then I can rewrite this like so by moving it over to that side. I could then take ln of both sides to get 3x, and then finally I can just divide 3 by 3. So it's 1/3 ln of 1 minus e to the minus 2. And that is a wrap. Thanks very much for watching. If you found that useful, please do subscribe to the channel, and I've got lots more A-level content this way, so check it out. Bye for now.